Hi, today we're going to revisit multiplying numbers using area models, also known as rectangle sections. For my first problem, I have 48 times 35. Now what I want to do is I want to decompose these numbers, make them user-friendly so that they're easier to work with. So instead of 48, think of what combination would give me 48. Can I use 40 plus 8? Can I use 40 plus 5 plus 3? Sure, they all equal 48. So in this case, I'm going to go ahead and use 40 plus 5 plus 3, or 48. My second number, 30 plus 5. And once you've decomposed those numbers, all you have to do is partition your rectangle and start multiplying. It doesn't matter in what order you multiply. You can multiply top, left to right, or bottom. It doesn't really matter. My preference is to start with the top and work my way to the right and then to the bottom. So 40 times 30 is 1200. 30 times 5 is 150. 30 times 3 is 90. 40 times 5 is 200. 5 times 5 is 25. And 5 times 3 is 15. When you have all your products, all that is left to do is to add them. Be sure that you are very careful with your addition. I highly recommend you use quadrille paper, which is that square paper, to keep every number aligned, one number per square. So after you finish adding, your answer is 1,680. Your final product is 1,680. I'm going to go ahead and also use standard algorithm to show my answer. You start off with your first place, the ones place. 8 times 5 is 40, carry my 4. 4 times 5 is 20, plus 4 is 24. Add a placeholder because now you're multiplying the tens place. 8 times 3 is 24. Carry my 2. 4 times 3 is 12, plus 2 is 14. I add. My final answer is 1,680. We have a match. So both of these methods can complement one another. You'll realize that in some situations one is better than the other, and it all just depends on the situation. For a second problem, we're going to be multiplying a 3-digit number times a 2-digit number using area model / rectangle sections. So our problem is 648 times 35. Now, however you choose to decompose these numbers, decompose them in a way where it's to your benefit, to your strengths, to your abilities. So set up your rectangle. Start by decomposing 35. That one's pretty easy. Probably going to go with 30 plus 5. Now for 648, you need to decide, do you want to go with 600 plus 40 plus 8? The only issue I have there is if you're not very proficient with your 8s, your times tables, as far as your 8s are concerned. If you're more comfortable with your 3s and your 5s, you might want to decompose that 8 to 5 plus 3. So you would have 600 plus 40 plus 5 plus 3, which equals 648. You can choose to do that. If you have no problem multiplying with your 8s, then go with your 8s. Once you have that set up, you go ahead and make your partitions, and you start multiplying. And all I'm doing here is using mental math. 6 times 3 is 18, add those 3 zeros. 3 times 4 is 12, add those 2 zeros. 5 times 3 is 15, add that 0. And 3 times 3 is 9, add the 0. And my class learned this using place value techniques, so now it's becoming very easy to do this mentally. Once you have all your products, then you're going to go ahead and find the sum of all the products. Be very careful when you're adding. It would really stink for you to make a mistake once you've come to the end of your problem, the addition portion. So please use quadrille paper, or maybe perhaps use a ruler to make lines. Keep all your numbers in the correct column. So my final answer is 22,680. Now I'm going to go ahead and show you how to do this using standard algorithm, just to make sure that we got the answer correct as well. For our last problem of the day, we're going to be multiplying a decimal times a whole number using an area model / rectangle section. So the problem we have is 24 2/10 times 12. So we set up our rectangle section. We decompose our 12, that's 10 plus 2. Now we're going to carefully decompose our 24 2/10. So we have 20 plus 4 for 24. Now remember, that's 2/10, that's 20 cents, that's 2 dimes. Remember that. So the easiest way is to label it. That's 2/10, so that you do not forget. Now you go ahead and partition. And I multiply 10 times 20 is 200, 10 times 4 is 40, 20 times 2 is 40, and 2 times 4 is 8. Now be careful with the decimal portion here. 10 times 2 is 20 tenths, not 20 wholes. And 2 times 2 is 4 tenths, not 4 wholes. So label it so you don't forget. Once you have that set up, separate your whole numbers from your decimals. So only add up your whole numbers. 200 plus 40 plus 40 plus 8 gives you a grand total of 288. And now the decimals. You have 24 tenths. Think money, 24 dimes. If you have 24 dimes, that's the same as $2.40. So include that into your equation over here. And I always like to add the decimals and the zeros just to make it easier for myself. So once I add all those numbers together, my grand total is 290 and 40 hundredths. Now using the standard algorithm, I set up my problem as though the decimal's not there. I multiply, add a place value, I add. My answer is 2904. Now remember about the decimal. Now you move it one place, so you do the same thing, but in the opposite direction to your answer. And your answer is 290.4, which is the same thing. So you have 290.4. That would be like $290 and 4 dimes versus $290.40, which is the same exact thing. So always think of it as that. 4 dimes versus 40 cents. Is it the same? Yeah, it is. Thank you for watching.